Hi everyone. So we will continue our chapter for your chemical kinetics. How we started chemical kinetics? We studied about the rate of reaction. What is rate of reaction? In which all reactions we can study the rate of the reaction. We studied that only those reactions which are not very fast, not too slow, we can only find those rates, right? Then we found about average and instantaneous rate. For average rate, it was delta reactant by time, and for instantaneous rate it was dA by dt with the coefficients and the signs, right? Then we studied about graphical representations of reactants and products. Tan theta, you remember we used to take a slope of it and all. So that's how we studied the rate of the reaction. Then we studied the factors on which rate of reaction depends, right? The nature of the reactants, homogeneous, heterogeneous, the concentration of reactant, the temperature of the reactant, and intensity of light, surface area, physical state, etc. The one thing where we got stuck upon was concentration of reactant, right? Why did we got stuck upon concentration of reactant dependence on rate of reaction? Because sometimes what was happening, the rate of reaction was increasing with increase in concentration, sometimes it was decreasing, sometimes it was not affected only, sometimes only one reactant rate was dependent upon the rate of the reaction, sometimes all the reactant were dependent upon the rate of the reaction, etc., right? So to solve this kind of problem, there came a concept called as rate law. There came a concept called as rate law. What does this law does? This law will explain, it explain the dependence of rate of reaction. It explains the dependence of rate of reaction on the concentration of species, on the concentration of the species in the reaction. So what does it do? It explains the dependence of rate of reaction on the concentration of species in the reaction, and it is actually very complex. Sometimes because the reactant is continuously decreasing, the product is continuously increasing, right? This dependence, it is very complex. Why? As it changes with change in concentration of species. As it changes with changes in concentration of species. So we are not going to study this much complex relation. We'll only study the simplest form. We'll only study the simplest form of dependence. And this simplest form is identified just experimentally. Very important. We don't have any formulas, we don't have anything like that to explain how the concentration is dependent upon the rate of reaction. This can only be done through experimental results. So only experimentally we can determine the rate of reaction and your concentration of reactant dependence. Only experimentally. Okay, so this is how your rate of reaction is determined on concentration of the reactant. For example, you have 2a plus b is giving me product. 2a plus b is giving me a product. Okay, now it's already given to us. Okay, they are telling experimentally seen. Experimentally, very important. Experimentally, they are telling us. Experimentally, the concentration of A is, whenever we are doubling the concentration of A, the rate of the reaction is also doubling. Okay, so how we can write it down? We can write it down as this thing, right? The rate of the reaction is doubling. So concentration of the reactant raised to the power 1. Why raised to the power 1? If I double the concentration of the reactant like 2, the rate of the reaction will also double, right? Like exactly same. So rate of the reaction is directly proportional to a raised to the power 1. Experimentally, it is also, see, like this is just a reaction, okay? Whenever you are doubling the concentration of B, the rate of the reaction increases 4 times. What happens to the rate of reaction here? It increases 4 times. So how do we relate it? Rate of the reaction is directly proportional to B raised to the power 2, right? Because it's doubling 4 times. So what does it mean? If I am increasing the B concentration by 2 ml, my rate of the reaction is becoming 4. So 2 raised to the power 2. Like whatever is it goes into coefficient. Now if we combine these both reaction, if we combine 1 and 2, what do I get? I'll get rate of reaction is directly proportional to A raised to the power 1 and B raised to the power 2, correct? If we want to remove the proportionality sign, I need to put a constant. Let that constant be K. So rate of the reaction is equal to your K raised to the power 1, B raised to the power 2. This K is called as my rate constant. Rate of the reaction is equals to K, A raised to the power 1 and B raised to the power 2. This is called as rate constant. This 1 and 2 is not fixed. You can just keep it as X and Y. So experimentally, if A is becoming double, ROR, rate of reaction is becoming double. So we can write it down. Rate of reaction is directly proportional to A raised to the power 1. If B is becoming double, my rate of reaction is increasing 4 times. So I can write rate of reaction is directly proportional to B raised to the power 2. Equate them, we'll get a equation ROR equals to A raised to the power 1 and B raised to the power 2. Okay. Now there were two scientists. With the name of Guldberg and Vage. Guldberg and Vage. Now the whole theory we'll study later, but just remember they were the ones who gave the mass of law action. Law of mass action or mass of law action. What did they tell? They are just directly telling that don't always like they are telling that don't depend experimentally but depend on the stoichiometry. So they were the ones who were telling don't depend experimentally too much on rate of the reaction. Don't depend on experiments, just see the stoichiometry. So they are telling rate of reaction will be equal to K, A raised to the power, the stoichiometry of A, B raised to the power of stoichiometry of B. Now B doesn't have a stoichiometry, it means 1. So they told this thing that depend upon the law of mass action. Just put the stoichiometry on the coefficient. But that didn't work every time. So we still stick to our experimental value only. Okay, now what was the experimental things? How do you keep in mind? For example, experimentally, if they are telling us, this is all experimental, okay, it changes every time. A might become half, B might become any time. We'll do more questions for your understanding. So supposingly if I am taking ROR, it's usually represented by a small r. Experimentally I am telling it's directly proportional to A raised to the power X, and your ROR, that is your R, is directly proportional to your B raised to the power Y. Now if I combine both these reactions with a constant, what will I get? Rate of reaction equals to K, A raised to the power of X and B raised to the power of Y. Right? Now this is very important. This is experimentally seen. Okay, I am not getting this data from anywhere. This was just experimentally seen. Now here my X will be, what will be my X? X will be my order of reaction. Order of reaction with respect to A. So this order of reaction can be anything. It can be a positive, it can be negative, it can be 0, it can be fractional value, anything. Okay. What is my Y? Y will be order of reaction with respect to B. Similarly, this can be positive, negative, zero, fractional, anything. What is your K? K is your rate constant. K is my rate constant, right? And my x plus y. X plus y will be equal to your n, which is the overall order of the reaction. Very important. X plus y equals to n, which is my overall order of the reaction. Overall order of the reaction. So experimentally, what was it seen? ROR directly proportional to A raised to the power x and B raised to the power y. Combine them. What is x? Order of reaction with respect to A. Y is order of reaction with respect to B. X plus y will be equal to your n. That is your order of the reaction. K is called the rate constant. Now this also has different names in different textbooks. Rate constant, or it is called as velocity constant, or it is also called as specific reaction rate. Specific reaction rate. Okay. Now, if my concentration, if all the concentrations of A and B, if concentration of A which is equal to your B and which is equal to your 1, all the concentration is equal to 1, then what will happen? My rate of reaction will be equal to your K. Rate of reaction will be equal to your K. And what will be the unit of K? Just put K here, rest everything you put in the denominator, you'll get the unit. So rate of reaction divided by A raised to the power x, B raised to the power y will be equal to my K, correct? Okay, let's do it in the next page. See, we studied rate of reaction equals to my K, A raised to the power of x, B raised to the power y. Now I need to find the unit of K. How will I find? Just put K on the right hand side, rest everything shifted on the left hand side. So rate of reaction divided by A raised to the power of x and my B raised to the power of y will be equal to your K. What was the rate of reaction unit? Moles per liter second inverse, right? And what will be the unit of this particular thing? Concentration unit only, right? So it will be moles per liter raised to the power of x and moles per liter raised to the power of y. Now just see the denominator, and we know from the previous lecture also that x plus y equals to n, that is your order of reaction. So that means I can write it like this also, right? Moles per liter second inverse upon moles per liter n, right? Moles per liter second inverse, moles per liter n. Now this n will shift in the denominator, you will get moles, this is 1, moles per liter 1 minus n second inverse. See, just remember it like this. Rate of reaction unit is moles per liter second inverse. Moles per liter second inverse. And what will be the unit of your K? K unit will be moles per liter 1 minus n. Moles per liter 1 minus n second inverse. Now what is this 1 minus n? Now if I substitute for zero order reaction, like just keep in mind, if I am just talking about my zero order of reaction, if my zero order reaction means my n is equal to 1. So for zero order reaction, what will be the unit? Just substitute n as 0. So the unit will be moles per liter second inverse. For my first order reaction, the unit will be 1 minus 1 equals to 0. So the unit will be second inverse. For my second order reaction, just substitute n as 2. If I substitute n as 2, so I'll get moles minus 1, n as 2 minus 1, right? Yeah. Moles per liter minus 1. No, liter will be plus 1 then, right? Liter second inverse. My third order reaction, or my say minus half order reaction. What will be half order reaction? Just substitute half. Moles per liter, 1 minus half. What is 1 minus half? Minus half, right? Minus half order reaction. So minus minus will become plus. So plus 3 by 2 second inverse. This is how you find the units of all the kind of reaction. Moles per liter, 1 minus n second inverse. What is the unit of rate of reaction? Moles per liter second inverse. Okay. Okay, so let's do few questions, very important questions. I think you'll get an understanding what is the order of reaction, how do we calculate the rate of the reaction. Okay, after this thing I think we'll do we'll start with then zero order reaction. Okay, so let's do some questions from this topic. Okay, the first question is telling us, if your rate constant, that is your K, is equal to your 3 into 10 raised to the power minus 3, just see the units, okay, L square, mole minus 2, second inverse. What do you need to find? Find the rate of the reaction. Now just pause this video and try it on your own. How do we, just think about it. How do we find the rate of the reaction? We can find the rate of the reaction from the units, right? But if you check here, units are not matching with any of the units which we found a bit ago. So how will we find it? See how we used to find the unit. Moles per liter, 1 minus n, S minus 1, right? And what unit is given to us? L square. So let me put L downwards. Moles minus 2, L square. So I can put it like this, right? Minus 2 and second inverse. Correct? Now just equate it and find the value of n. Write on your own. Find the value of n. So this second and second gets cancelled. This and this is also getting cancelled. So what is left? 1 minus n equals to 2. So my n will be equal to 3. So this will be my third order reaction. This is how you find the order of reaction with whenever such kind of question is given and whenever just the units are given. Okay. Now a big question for you all. I'll give 2-3 such kind of questions. First question I'll do, rest 2 you guys try to do it. Okay. Okay, the question tells us 2a plus 3b is giving me product. 2a plus 3b is giving me the product. And they are telling us order of reaction with respect to A is 2 and with respect to B is minus 1. So what do you have to do here? You have to write a rate law expression and calculate the order of reaction. Calculate the order of reaction. First you do these both and then we'll do the rest. The rest of the parts are also there. So rate law expression. How do we write the rate law expression? So everything is already given to us, right? Order of reaction with respect to A is 2, B is 1. So how will we do it? Rate of reaction is equal to your K A raised to the power 2 and B raised to the power minus 1. How will we calculate order of reaction? X plus Y. So order of reaction will be 2 minus 1 will be equal to your 1. So order will be my first order reaction. Now the second, now what you have to find? Now they are telling us concentration of A is doubled alone. Concentration of A is doubled alone. So they are telling what will be the effect on rate. What will be the effect on rate? So what will be the effect on rate? See, just compare the first rate with your second rate. First rate, the original rate. What is the original rate? Original rate is this, right? Let us consider this as R. So my R is already my K, A raised to the power 2 and B raised to the power minus 1. Now they are telling if your concentration of A is doubled, concentration of A, now my new R, say my R dash will be K 2A raised to the power 2, right? Why? Because they are telling us concentration is double. Now just do, this is my first equation, this is my second equation. We need to compare this thing, what will happen? So just what you do is, just divide R dash by R. 2 by 1, just do 2 divided by 1, full equation. So R dash by R equals to my K 2A raised to the power 2, B raised to the power minus 1 divided by K A raised to the power 2, B raised to the power minus 1. So what all get cancelled? Just cancel them. K and K get cancelled, B raised to the power minus 1 and B raised to the power minus 1 gets cancelled. If I just write it again. So R by R dash will be equal to 4A square by A square. So A square and A square get cancelled. Sorry, this is R dash by R, right? Yeah. So R dash by R will be equal to, so R dash becomes 4 times. So it means the original, now the rate will become, rate is increasing. This was the new rate. This is my new rate, this is my old rate. This is my new rate and this is my old rate. So what happens to the new rate? The new rate increases 4 times. The new rate increases 4 times. Okay. So this is how you do the questions. Only these kind of questions will come for this topic. I'll give you second part also to do. Okay, the second part is telling us concentration of B is halved alone. So what will be the new rate? Like how is the rate affected? That's the same question. Okay. So now you know the original rate was A raised to the power 2 and B raised to the power minus 1, right? New rate, what are they telling? B, you are doing it half. A is same and B, you are doing it half. Half means 1 by 2, right? Same thing, only do 2 divided by 1. Now what are we doing? 2 divided by 1. So this will be equal to R dash by R, which is equal to your K, A raised to the power 2, B by 2 raised to the power minus 1 and divided by K, A raised to the power 2, B raised to the power minus 1. What all you need to cancel? Just cancel K, A raised to the power 2, A raised to the power 2. What do you get? R dash by R equal to B raised to the power minus 1, 2 raised to the power minus 1 divided by your B raised to the power minus 1. Now B raised to the power minus 1, B raised to the power minus 1 gets cancelled. What do you get? Simple maths. R dash by R equals to 1 divided by 2 raised to the power minus 1. So 2 raised to the power minus 1, I can write it as 2 also, right? So what happens to your new rate? New rate is increasing 2 times. New rate is increasing 2 times. Okay. Third part. Third part, they are telling us, now both rates are doing something, okay. Concentration of A and B both is doubled. Concentration of A and B, what are they doing? Both is doubled. Okay. So what was our original rate? Rate equals to K, A raised to the power of 2, B raised to the power minus 1. This was original equation, right? As given here. New rate will be, both are doubled, right? So we are writing 2A square, 2B raised to the power minus 1. Just do 2 divided by 1. 2 divided by 1, r dash by r, which is equal to your k 2 raised to the power a square 2b raised to the power minus 1 divided by k a raised to the power square b raised to the power minus 1. So what will happen? Your k and k will get cancelled. What is the ultimate thing? 4a square 2 raised to the power minus 1 b raised to the power minus 1, just opening the brackets, divided by a square b raised to the power minus 1. What all things can get cancelled? This thing will get cancelled, this thing will get cancelled. What is left? 4 into 2 raised to the power minus 1, which is equal to 4 divided by 2, which is equal to your 2. So r dash by r will be equal to your 2, and if you cross multiply 2r, right? So it means rate is again increasing 2 times. Rate is again increasing 2 times. Okay, the fourth part. Very easy, this thing, just you need to properly divide it. Fourth part is telling you, okay, this is important, volume of container. Now this time what they are doing, volume of container is increasing 3 times. They have increasing 3 times. Okay, how do you do this thing? Just check the relation between your concentration and volume. See, you know the formula, concentration equals to concentration will be equal to moles per liter. What are they doing? They are increasing the concentration by 3 times. So if I am increasing the volume by 3 times, it means my concentration is decreasing by 3 times, correct? So volume of the full container, they are increasing 3 times. It means the concentration is actually decreasing by 3 times, right? See, the original was r equals to k a raised to the power, I think it was 2, 2, b raised to the power minus 1. Then what are they doing? The new concentration will be k a raised to the power 3. Why? Because your volume is increasing, it means concentration will be decreasing. So moles per liter, right? So this thing will be 2 b raised to the power 3 raised to the power minus 1. Now just do 2 divided by 1. What will be 2 divided by 1? R dash by r will be equal to your k a raised, I am writing it 3 by 2 b by 3 minus 1 divided by your k a raised to the power 2 b raised to the power minus 1. Just cancel all the remaining things. A square by 3 square. What is 3 square? 9, right? B raised to the power minus 1. 3 3s are 9, yeah. And 3 raised to the power minus 1 here. A square got and divided by a square b minus 1. This and this get cancelled. What do you get? 1 by 9 into 1 by 3 raised to the power minus 1, which is equal to 1 by 9 into 3. 1 by 3. So, what do you get? R dash by r equals to your 1 by 3. So, r dash equal to new r will be r by 3. So, rate is decreasing. So, what happens if you increase the volume of the container by 3 times? The rate will decrease 3 times. Decreasing 3 times, right? So, rate is going to decrease 3 times. Okay, next question. Try it on your own. It's easy maths what you have to apply exactly if you know the concepts. The question is, they have given us a reaction. Okay, 2a plus b is giving me product. 2a plus b is giving me product. So what reactions you have to write? When a is doubled alone, when a is doubled, ROR is increasing 2 times. ROR is increasing 2 times. and when both A and B are doubled. When both A and B are doubled, the rate of reaction is increasing by 8 times. Rate of reaction is increasing 8 times. So what you have to do? Rate law expression you have to write. Write the rate law expression, and nothing you have to do, find the order of reaction. Very easy. Just normal logic. How do you write the rate law expression? The rate of the reaction will be equal to your K. What is happening when A is doubled? See, exactly it should be A raised to the power X, B raised to the power Y. This should be our reaction, right? Let my rate of the reaction be R. Now what are they telling when A is getting doubled? This is my first reaction, suppose. Next they are telling when rate of the reaction, when A is getting doubled, my B is the same, right? My rate of reaction is getting double. Let it be 2R. It's becoming 2R. In next equation they are telling us when A and B both are getting doubled. A and B both are getting double. Rate of reaction is increasing 8 times. Now this is the rate law expression. You have to find what's going to happen. Like you have to find the x and y. Simple. 3 equations are given. You need to find the x and y and just add them then. See, what we can do is we can just divide 2 divide by 1 so that your b get cancelled. First let us try your 2 divide by 1. The second reaction is 2r divided by r, which is equal to your k 2a raised to the power x, b raised to the power y. And my r will be k a raised to the power x, b raised to the power y. Why did I chose 2 and 1 only? So that my b and b get cancelled here. So if I cancel them, what do I get? Like this and this gets cancelled, this and this gets cancelled. My a raised to the power x also gets cancelled. Sorry, not a raised to the power x. So what do I get in the remaining? 2r by r will be equal to my 2 raised to the power x. R and R also gets cancelled. 2 equals to 2 raised to the power x. So what will be x here? X will definitely be going to be 1 because 2 raised to the power 1 is 2. Any other number will not suffice. So this is how you do it. We found the x. Now we need to find the y also. How will I find y? Do something so that your this and this gets cancelled, right? 2 divided by 3. Let's do, or just do 3 divided by 2. So this one will be 8r divided by 2r will be equal to k 2a raised to the power x, 2b raised to the power y divided by k 2a raised to the power x, b raised to the power y. 2r get cancelled by 8r, 2 4s are 8. So 4 equals to this and this completely gets cancelled. 2b raised to the power y and b raised to the power y, b raised to the power y will gets cancelled. B and B gets cancelled. So what is remaining is y. So 4 equals to 2 raised to the power y. So what will be y here? 2. 2 raised to the power 2 is 4, right? So y equals to 2, x equals to 1. So what will be the order of reaction? The order of reaction will be here 2 plus 1, which is equal to your 3. So how do you write the rate of reaction equation? K a raised to the power 1, b raised to the power 2. Easy. Just you need to come up with such an equation so that you get the values of x and y. Okay, next question is also the same. Similar question I'm giving you, but 4 reactions here. 4 reactions I'll give you here. The question tells you this is the reaction A plus 2B plus C is giving me product. Now, what is the equation? First, form correct equations. If you don't form correct equations, ultimately your formulas are wrong. When volume of container, what are they telling? When volume of container is doubled, means concentration is halved, ROR is decreasing 8 times. And what are they telling? When A is doubled, next equation they are telling, when A is doubled, B is halved, ROR increases 4 times. C increases 4 times. When C is increased 4 times alone, the ROR increases 64 times. ROR is increasing 64 times. Same thing, you have to find the rate of the reaction and order of the reaction and all. Let us write the equations. We know K will be equal, your rate of the reaction R will be equal to A raised to the power X, B raised to the power Y, and C raised to the power Z, XYZ. This is my first equation. Second equation, volume of container is doubled. All the container is doubled. So it means the concentration is halved. A by 2 raised to the power X, B by 2 raised to the power of Y, C by 2 raised to the power Z. The rate is decreasing. So means you are getting R by 8. Third time what is happening? Let it be R dash. Okay, rate is decreasing. Then A is double, B is half. R increases 4 times. So R is becoming 4 times when A is doubled. A is doubled and B is halved. Okay, C, they are not telling anything. It means it is same. This is my third equation. Fourth, what is happening? C is alone increasing 4 times. The ROR is becoming 64R. So A raised to the power X, B raised to the power Y, and C is increasing 4 times. 4C raised to the power Z. So these are the 4 equations. What you need to do is do something out of it that you get X, Y and Z. X, Y and Z. Let us do one thing. Let us do 1 divided by 2. So that you get an equation. If you do 1 divided by 2, you will get 8 equals to, I think so, 8. You are doing 1 divided by 2. I am writing the final equations. Okay, 8 equal to, see, all the 2's will come in above side, right? So 2 raised to the power X plus Y plus Z, right? So here you will be getting X plus Y plus Z. X plus Y plus Z equals to, see, 2 raised to the power, what thing is 8? 2 2s are 4, 4 2s are 2 raised to the power 3, right? So this is our first equation. Suppose X plus Y plus Z equals to 3. Then what should we do? What if I do 4 divided by 1 so that this and this all gets cancelled? 4 divided by 1. If I do my 4 divided by 1, I'll get 64 equal to 4 raised to the power Z. How much 4 raised to the power Z it is? 4 4s are 16. 16 into 4? 64. So 4 raised to the power 3. So Z I got it as 3. So Z I have already got it, right? Now we know Z, right? Now what we do, let's do 3 divided by 1. Just random things I am taking. 3 divided by 1. So 3 will be 4 equals to 2 raised to the power X. 3 divided by 1. Yeah, 2 raised to the power X. I think it will be minus Y and C gets cancelled. So this will be X minus Y. equals to 4. So x minus y will be equal to your x minus y, 2 raised to the power dash. So I can write this thing as 2 raised to the power 2 also, right? So x minus y equals to 2. These three things we have got, okay? Yeah, so now I think so we can find it out. What all equations we have? X plus y plus z is equal to your 3. So that will mean x plus y equals to 0, right? Because z is my 3. So if I substitute x plus y plus 3 equals to 3. So x plus y equals to 0. And I know x minus y equals to 2. So I got x as 2. If I get x as 2 here, 2 plus 3. No, 1 minute. It will be 2x, right? 2x, I'm adding this, 2x. So x equal to 1. If I get x as 1, 3, 4. 4 minus 1. So y will be minus 1. So what will be your order of reaction? Your order of reaction will be 1 plus minus 1 plus 3. 4 minus 1, 3. So this will be your third order reaction. And how do you write the xyz? Just write here 1, here minus 1, and here your 3. So order of reaction is okay. So just practice all these things because it's simple maths. You just need to find xyz every time. Okay. Now some important points about order of reaction. Some important points about order of reaction. What is the first important point? Whatever first thing was like whatever Goodberg and Wack told us that it depends upon the stoichiometry, that's not correct. The first point is stoichiometric coefficient. Stoichiometric coefficient has nothing to do with the order. Stoichiometric coefficient has nothing to do with the order. We don't care about what the stoichiometric coefficient is telling us. Like for example, if you have N2O5 giving us 4NO2 plus O2. Now we might assume that your rate of reaction will be the stoichiometric coefficient of N2O5, right? But that's not correct. Actually, experimentally, the rate of reaction was equal to your K N2O5 raised to the power 1. Experimentally. The second thing, concentration terms of products. In rate law, your concentration terms of product can also, because usually you are taking reactants only, right? So concentration of products can also be present. Concentration of products can also be present. For example, you have a reaction O3 gives you O2, 2O2. Experimentally, it was seen that the rate of reaction was equal to your K O3 raised to the power of 2 and O2 raised to the power minus 1. Now there is concentration of product also, right? So this thing can also happen. Next thing which you need to keep in mind is concentration of some reactant might be absent. Concentration of some reactant can be absent. For example, if I take NO2 plus CO is giving me NO plus CO2. So rate of reaction here can be K NO2 raised to the power 2. So here no CO is present. This is everything ROR, whatever I am writing, it is experimental. Nothing of any formulas. Fourth thing, sometimes there may be catalyst also present. In rate of reaction, there may be catalyst also present. Like example 2SO2 plus O2 is giving me, in the presence of NO, catalyst is giving me SO3. So sometimes what happens, the rate of reaction will be equal to experimentally O2 and NO1. This is NO is catalyst, but since still catalyst is present, so we cannot predict what the rate of reaction will look like unless it is experimentally mentioned. Okay. Then okay, one last topic which you need to study in this video is your simple reactions. They're also called as elementary single step reaction. Simple reaction or your elementary single step reaction. What is single step? Like self-explanatory, right? It happens in a single step. What is a complex reaction? There are two kinds of reaction, okay? Simple and complex. What is a complex reaction? Complex is something like this. 2a plus 3a plus 2b is giving me C. Complex reactions happens in many steps. I'm talking about your complex reaction. Complex reactions happens in many steps. For example, you have in this my step 1 is 2a plus b is giving me P. Step 2 is P plus A giving me Q. Step 3 is Q plus B giving me C. What is the overall reaction? B will become 2B here. A will become 3A here is giving me C. Rest everything got cancelled. Okay. So complex reaction is something which happens in many steps. Single step happens, finishes in one step. Okay. Now in simple step, in whatever reactions are single step reaction, in those kind of reactions, in your slow step or say your RDS step can be used to determine the stoichiometry. To determine the stoichiometry in complex reactions. Like complex reactions, suppose step 1 was, there were many steps, right? Step 1, step 2, step 3, like how we studied previously. Suppose step 1 was my RDS step, slow step. So here, like P, it was giving me P, I guess. So here this step was RDS. So now I can predict my rate of reaction according to whatever step is slowest. So rate of reaction will be equal to K A raised to the power 2 B raised to the power 1. Why? Stoichiometry we are taking. Stoichiometry. Okay. Now in single step reactions we can also use rate of reaction by stoichiometry. Whenever the reaction is a single step, this is where the Goldberg and Wag law comes into existence. They are telling us whenever you have single step like H2 plus I2 is giving me 2HI. This is simple reaction, right? This is simple reaction. So what will be my rate of reaction? Nothing I have to do. Just take K, H2 raised to the power 1 and I2 raised to the power 1. In simple steps, the Goldberg and Wag rule follows. In simple step reactions, the Goldberg and Wagge law of mass action will follow. Just take the stoichiometry for your rate of reaction. Example, just try to write the rate of reaction of this single step reaction. H2 plus Cl2 is giving me 2HCl. If you assume this to be single step reaction, you might tell that this is how you write the single step reaction. But experimentally, but there is a huge but here. But experimentally, it was seen that my rate of reaction was not dependent on anything. So this particular thing will confirm that okay, this reaction is not a single step reaction. Okay. So this law is basically used only for single step reactions. Okay, now in next, from next video we will, I think, cover your, you will start your zero order reaction. Okay, zero, then first order, second order, third order, and then we'll come to a point where we get to know how to find the exact order of reactions. Okay, so that's it for this video. Thank you so much everyone.